Hello, my name is Jungwook Lee. I'm a master's student working for Dr. Stein at the University of Illinois. The presentation I'm going to talk about today is on effects of tallow, palm kernel oil, corn germ, and glycerol on gross performance and carcass characteristics of finishing pigs fed DDGS based diets. This presentation I'm going to talk about today consists of a short introduction, and I'll briefly talk about how we conducted our experiment. I'll discuss gross performance, carcass characteristic, belly flop distance, and a short conclusion at the end of this presentation. As a little bit of background, distillers' dry grains with solubles, DDGS, is a co-product produced from ethanol industry. It's a valuable feed ingredient for swine diets because of high ME value, which is similar with corn, and high protein and digestible phosphorus and fat content in DDGS. It's been reported that up to 30% of DDGS inclusion in the swine diets showed acceptable performance. For the past few years, many swine producers attempt to use greater inclusion rate of DDGS because there's been increased availability of DDGS due to the greater production rate from ethanol industry. It is economical to use a greater inclusion rate of DDGS in the swine diets. However, it's been reported that 20% or more DDGS inclusion in the diet may result in soft belly production. The primary reason for soft belly production is due to the high amount of fat, which contains primarily unsaturated fatty acid. This diagram shows fatty acids profile of DDGS fat. As you can see, approximately 80% of total fatty acids in DDGS are unsaturated. About 51% of fatty acids are polyunsaturated fatty acids. Therefore, the ratio of unsaturated to saturated is relatively high. When pigs are fed DDGS-based diets, these highly unsaturated fatty acids directly incorporated into pig's fat and result in belly softness. A soft belly has undesirable physiochemical properties. It results in poor bacon slicing, lean and fat separation, and low quality bacon. Moreover, soft bellies contain a high amount of unsaturated fatty acids, which are very susceptible to oxidation, therefore reducing shelf life and low storage stability. Swine producers and packers will be financially penalized by these undesirable low belly quality and problems associated with soft belly production. Therefore, the objective of our experiment was to determine if negative effects of DDGS on fat quality can be ameliorated by including tallow, palm kernel oil, corn germ, and glycerol in diets fed to finishing pigs. We used 6 dietary treatments. Diet 1 consists of corn and soybean meal-based controlled diet with no DDGS and no added fat. Diet 2 consists of corn and soybean meal diet with 30% DDGS. Diet 3 consists of Diet 2 with 15% corn germ. Diet 4 consists of Diet 2 with 3% tallow. Diet 5 consists of Diet 2 with 3% palm kernel oil. Diet 6 consists of Diet 2 with 5% glycerol. A total of 36 barrels and 36 gilts with an initial body weight of approximately 43.7 kilograms were used in our experiment. There were 12 replicate pigs per diet. All pigs were housed individually, and pigs were allowed ad libitum access to feed and water throughout the experiment. A two-phase feeding program was used in our experiment. Early finisher diets were fed during the initial 42-day, and late finisher diets were fed during the final 46th day of our experiment. Data for average daily gain, average daily feed intake, and gain to feed were calculated for each pig and summarized for each gender and each diet at the conclusion of our experiment. After an overnight fast, pigs were transported to the meat science laboratory at the University of Illinois and were slaughtered, then carcass composition and belly flop distance were determined. Here's a picture describing how we conducted the belly flap distance of each pig. The belly flap distance was used to determine belly firmness of each pig. A flap test was performed by draping a belly sample over a suspended stainless steel rod with the skin side down. The distance from skin surface to skin surface were measured at a standardized point 10 centimeters down from the stainless steel rod for each belly. Data were analyzed using proc mix of SAS. Pigs were randomly allowed to one of 6 dietary treatments in a 2x6 factorial design. Treatment, sex, and the interaction between treatment and sex were fixed effects. Block was a random effect. However, the interaction between treatment and sex was not significant for any of the variables analyzed. Therefore, the interaction was removed from the final model. Only main effects will be presented. Results. This slide shows data for average daily gain of pigs during the entire period. On the x-axis, 6 different dietary treatments were represented by different colors. A yellow bar representing Diet 1 control diet, a green bar representing DDGS diet, a red bar representing corn germ diet, a blue bar representing tallow diet, a purple bar representing palm kernel oil diet, and a gray bar representing glycerol diet. There were no effects of dietary treatments on average daily gain during the entire period. All the pigs have gained close to 1 kilogram daily, and they were healthy throughout the experiment. Here's a slide showing average daily feed intake for pigs fed the experimental diet. There was a tendency for reduced average daily feed intake of pigs fed palm kernel oil diet compared to average daily feed intake of pigs fed the control diet. Other than that, no other differences in average daily feed intake among the dietary treatments were observed. This slide shows gain to feed among the dietary treatments during the entire experimental period. Pigs fed the palm kernel oil diet tend to have greater gain to feed compared to pigs fed the glycerol diet and the control diet. Other than that, no other differences in gain to feed among the treatments were observed. This slide shows belly flap distance among the dietary treatments during the entire experimental period. The flap distance was greater for pigs fed the control diet than for pigs fed the other 5 diets containing DDGS. However, there were no differences in belly flap distance among the diets containing DDGS. Belly flap distance can be used as an indicator for belly firmness of each pig. A reduction in belly flap distance indicates belly softness. Adding DDGS into the diet significantly reduced belly flap distance compared with bellies from the control pigs. However, the addition of corn germ, tallow, glycerol did not ameliorate the effects of DDGS. When DDGS is included in the swine diet, it's been shown to result in soft belly production due to the high fat in DDGS containing mainly unsaturated fatty acids. This result agreed with previous studies which showed an increase in belly softness in pigs fed the DDGS-based diets. This slide shows the average daily gain for barrows and gilts. Here's an orange bar representing barrow and a green bar representing gilt. As you can see, barrows gained more weight than gilts during the entire experimental period. Here's a slide showing the average daily feed intake for barrows and gilts. Barrows consumed more feed than gilts during the entire experimental period. This slide shows data for gain to feed for barrows and gilts. Gain to feed for gilts were greater than for barrows during the entire experimental period. Barrows had heavier hard carcass weight than gilts. This slide shows the backfat thickness for barrows and gilts. Barrows had greater backfat thickness than gilts. This slide shows belly flap distance for barrows and gilts. Barrows had greater flap distance than gilts. Our results also agreed with the previous studies which showed The barrels tend to have firmer bellies than gills. Conclusions: 30% DDGS can be included in corn soybean meal based diets without any negative impact on growth performance. The negative effect of DDGS on pork fat quality were now ameliorated by including tallow, palm kernel oil, corn germ, and glycerol in diets fed to finishing pigs. The data presented today are the results of our first stage of our experiment. The second stage of our experiment is being conducted now. Data will be presented at ADSA ASAS Joint National Meeting in July 2011. Thank you so much for your attention.